So to figure out how to find the expected numbers for any particular question in chi-squared, you have to look at the Punnett square that you've drawn, the ratio that you've made, and then use the numbers from the data in the question to figure out what the expected numbers are. So I'll give you an example. We did an experiment with, let's say, 120 plants. So there's 120 plants in total. We found that 86 were blue, and Christ, I can't do this in my head, sorry. 120 minus 86, and we found that 34 were pink. Okay, so from this we can see, or maybe it was given to us that the cross that we used was two heterozygous, or maybe a heterozygous and a homozygous recessive. So we'll say that big B will be for blue plants and little b will be for pink plants. And it's asking us to see if the results from this are in accordance with, or if they match what our expected numbers would be. So we'll say that we had a heterozygous parent plant and let's go for homozygous recessive parent plant. We would then have this as our probability matrix, as our Punnett square. We would assume that for these 120 plants that were bred from a heterozygous parent and a homozygous recessive parent, that we would have 50-50 blue to pink. Or we could even say that there was a 2 out of 4 chance of a plant being blue and a 2 out of 4 chance of a plant being pink. The ratio here would be 1 to 1. So what would we expect if we had 120 plants? We'd expect that 60 would be blue and that 60 would be pink. Okay. Now that's not what we got. So in our chi-squared setup, the observed for blue and the observed for pink. So the observed for blue was 86 and for pink was 34. The expected that we would see was 60 and 60, and we do our O minus E. Our O minus E, and I'm going to do that in the calculator again. Minus 26. And we would do our 26 squared, 676. Then our O minus E squared over E for blue and for pink. So 676 divided by 60. 11.27, and for pink 676 minus 34 divided by minus 60, same thing, 11.27. Add those together, giving us 22.54. So that would be our chi-squared, and our degrees of freedom would be 1. Then we have to look up on the table and see if our p-value is less than 0.05. I don't have the table with me right now, I'm afraid, but that's it. So if what I think is right, the trouble that we're having is with figuring out this, something a little bit more complicated. So let's say the same thing. 120 plants, and we had 100 were blue and 20 were pink, and we had 2 heterozygous parents using the same code that we were using last time. So big B is blue and little b is pink. We would say that there is a blue there, blue there, blue there, pink there. So it's a 3 to 1. We would expect 3 blue plants for every 1 pink plant. if there's 120 plants in total, then using this probability ratio, I would get my 120 plants divided by 4, because there are 3 plus 1 is 4. I would expect 30 pink, and 3 times 30, I would expect 90 blue. So these would be my expected results if this probability were true. So again, OE, O minus E, O minus E squared. For blue and for pink, the observed that we saw for blue was 100, the expected we'd get is 90. The observed we saw for pink was 20, the expected would be 30. O minus E is 10, O minus E is minus 10, 10 squared is 100, 100. 100 divided by 90, 1.11, and a 100 divided by 30, 3.33. So the sum of those two will give me my chi-squared of O minus E squared over E. Will give me 4.44 as my chi-squared value with 1 degree of freedom, because there's 2 categories. Okay, so find your ratio and then work out, based on 120 plants, if this ratio was true, what would we expect to see in the results. So this is the observed results that we actually saw. These are the expected results that we'd see based on ratio and probability.